Okay, so we're going to do merge two sorted lists. It's essentially the same as merge two sorted arrays, right? So you're given the heads of two sorted linked lists, list one and list two, and you merge the two lists in a one sorted list. The list should be made by splicing together the nodes of the first two lists. Return the head of the merged linked lists. So you can't like just put them into like some array, sort them and put them into some array, then transfer them into some list, right? Into a linked list. So we're going to use this example to illustrate it via drawing, and then we can code it out, right? So we're going to have list 1, 1, 2, 4, and then list 2, which is 1, 3, 4, right? Okay, so these are our two lists. So the way we solve this is, make sure you've done merge two sorted arrays before doing this, right? And you also know how to implement merge sort, right? So the way we do this is we create a node, right? We'll initialize it to -1. So we create a head node, which we've initialized to 1, right? So this is our head node, right? Then we'll create a traversal node, which we'll call cur, right? We create a traversal node called cur, which will iterate over head, right? So since it iterates over head, it will enable us to set head's next pointers, right? So current dot next, right? Current dot next will equal to the smaller of these two, right? So whichever is smaller, we append this. So we'll grab this and append it to current.next, right? So our current, let me actually put it here. So that's what current.next does. After that, we need to move our current to the next portion, right? So our current comes like this, and it moves here, right? Then we check which one is larger, the one at list 2 or list, we also have to move our list 1 pointer. So we'll have, say, list 1, let's write it here, L1 and L2. So it's now at this position. It's now at this position, this is at this position. So again, we check which one is the smaller of these two. It's the one at L2. So we use current.next. We place it over here, right? And then we move this list 2 to this position, and then we move our current to this position, right? Remember okay, then we come again to these. We compare which one is a smaller, this or this, right? It's this. The 2 is smaller, obviously. So we move it here. And then we move our current to this next position. And then we move our list pointer to the next position. Then we compare again, which one is smaller, this or this? It's obviously the 3. We grab the 3 using current.next, we put it here, and then we move our pointer onwards. So it's important not to forget to move these pointers, and then we move our current onwards, right? And then again we now check which one is smaller, this or this, either one. We move it here like this. So at this point, this one is empty, but this one still has values. So after we're done doing this, we iterate through list 1 and list 2 for any leftovers. So list 1, there are no leftovers, it's now none. But list 2, there's a leftover, so we set our current.next to this, which will come here. Let me just erase this. Which will come here. And then remember our, we had forgotten to move, our current was here. We move it to here. And then here. Right? I forgot to move current. So now current is at none. And then so now our list 2 is also equal to none. So we're done with this. Right? Our current is now equal to none. And then our head, we simply move our head to this position. Right? Because our head was pointing, current.next had set it to this. So we return head.next. Right? So let's do this in code. Right? So in code, we initialize our head pointer, or what it's usually called our dummy node. Our dummy node, we can call it dummy, is equal to list node -1. This is the class. This is how we initialize it, right? It will have a value of 1. Then we use a traversal variable to traverse the dummy node. So char is equal to dummy. Right? Then we iterate through both list 1 and list 2 and add the smaller value to the dummy node. So while list 1 and list 2, why do we say while list 1 and list 2? This means while list 1 is not none and list 2 is not none. Other ways of writing it would be list 1 does not equal to none and list 2 does not equal to none. Right? So we add to dummy, to char, the smaller, the node with the smaller value. Right? So if list1 dot val is less than list 2, let's say less than or equal to, right? Because this will deal with the events that it's equal to, you just simply place there. But in any case, as long as you can even leave it. So if list 1 is less than list 2 dot val, right? We add list 1's node to char's next. So char.next, remember char is in charge of providing the nexts to the dummy variables. Char.next is equal to list 1, right? So we now move list1 pointer forward. So list1 is equal to list1.next. And since we want to continue adding, we move our traversal node forward. What's our traversal node? Cur is equal to cur.next. Else we add list2. So list2 will either be greater or equal to, so this means list2 is greater or equal to list1, right? So we add list2 node. So this will be cur.next is equal to list2, and then we move list2 forward. So we move list2 forward. So it will be list2 is equal to list2.next. And then again, we move our traversal. We move our traversal node forward, our traversal pointer. So cur is equal to cur.next. So once all this is done, let me put it here. So once all this is done, we'll be at that position. Remember that position whereby we had list1 was empty for this example, right? List1 was empty, but list2 still had a value, which was this 4, right? But there are certain cases where list1 may still have values and list2 may still have values, right? Actually, not both of them, because one of them will get done. So, but you don't know which one. You don't know which one. So you have to sniff through the remaining. You have to sniff through the remaining values. We don't know which one. List1 or list2 could still have values, right? And this is why we use AND. So for the length of the shorter one, we're going to merge all of them in sorted order to the dummy node. So list1 or list2 could still have values, but we don't know which one. So while list1, you could write this as while list1 does not equal to none, right? You can either copy this code here or you can rewrite it. So current.next is equal to list1, and then list1 is equal to list1.next, and then current is equal to current.next. So while again list2 current.next is equal to list2, and then list2 is equal to list2.next, and then current is equal to current.next, right? So after we're done with this, we'll be certain that current, so current is at none. We don't want to return the dummy, but dummy.next. So we return dummy.next, right? And we can, let me show it to you here. It's what we did here. Remember where we had, here we called it head. So we returned head.next, right? So we didn't return this, we returned this, right? So, and this is done in n time, and the space complexity is actually O1 space complexity. So let's run the code. Dummy is not defined. Oh, I wrote it with a capital D. I guess I could change it here. Okay, voila, it works. And that is a solution to merge two sorted linked lists. Sorted lists, right? So I'm just going to copy this. And this is done in n time O1 space. So that's the solution. Thank you.